This video discusses the procedure for the solutions experiment for general chemistry at Madison College. For this lab, you're going to be making 4 different solutions, and you have to do several calculations before you can begin the experiment. So for example, with solution number 1, you're going to be making 100 milliliters of a 0.25 molar solution of copper sulfate. The first thing that you have to calculate before you can even begin the experiment is you have to calculate how much copper sulfate pentahydrate do you need to weigh out. Your instructor will review these calculations before you start the experiment and check to make sure that you have the correct number before you begin the experiment. So you want to weigh out the copper sulfate, and you'll see that there'll be bottles of this by the balances in the lab. You want to weigh that out into a plastic weigh boat and then transfer it into a 100 milliliter volumetric flask that looks like this. What you want to notice about the volumetric flask is that there's only one line on it, and it's kind of hard to see in this picture, but that one line appears in the long neck of the volumetric flask. You can only do one volume measurement with a volumetric flask, but it's really accurate to use, especially when making solutions. You're going to use this same volumetric flask for each solution that you make as part of the lab. So you want to use a plastic funnel and transfer that solid copper sulfate into the volumetric flask. And then you want to add deionized water to dissolve the copper sulfate. Add deionized water until the water fills the bottom bulb of the volumetric flask, and then put the cap on and invert the flask several times until the copper sulfate dissolves. It takes a little while for the copper sulfate to dissolve completely, so just be patient and it will dissolve. Just give it a little bit of time. To get 100 milliliters of solution, you want to slowly add deionized water until the bottom of the meniscus lies on that line that's on your volumetric flask. It's really important to add the water slowly. If you go too far, if you accidentally add too much water, your solution is going to be too dilute, and there's no easy fix for this. You really have to go back and start all over again. So my suggestion for adding water slowly to your volumetric flask is to use the squeeze bottle of deionized water or use a disposable plastic pipette, and that way you can start adding water 1 drop at a time as you approach the line on the volumetric flask. You want the bottom of the meniscus to rest at the line, and you might be able to see that in this picture here. After you have the correct volume of solution number 1, you want to transfer it into a labeled beaker so that you can reuse your volumetric flask. You're going to be using solution 1 later in the experiment, so you want to store it in a beaker until you get to that later part. At this point in time, you're ready to do solution number 2, and you're going to make this exactly the same way, only this case your solute is going to be sucrose. Before you do the experiment, you need to calculate how much sucrose you need to weigh out, and you want to weigh out that amount of sucrose into a plastic weigh boat. You'll find bottles of sucrose by the balances in lab along with labeled scoops. So you want to weigh out the solid sucrose into a plastic weigh boat, and then you're going to transfer it into that 100 milliliter volumetric flask just like you did before. You want to add deionized water to dissolve the sucrose, and then slowly add deionized water until the bottom of the meniscus rests on the line in your volumetric flask, just like you did before. At that point in time, you'll have 100 milliliters of 0.25 molar sucrose. You'll want to transfer solution number 2 into a labeled beaker and save it for the next part of the experiment. So this is solution number 2. This is going to be your sucrose solution. The next solutions number 3 and 4, are going to be dilutions of your stock solution. And the stock solution that you're going to be using is solution number 1. That's the copper sulfate that you already prepared. So the calculation that you need to do for solution number 3 is you have to calculate how much stock solution do you need to make 100 milliliters of 0.1 molar copper sulfate. So you're going to want to measure out that volume of stock solution in a graduated cylinder. And remember that stock solution is solution number 1 that you've already made. You're going to pour that into your volumetric flask, and then to dilute it, you're going to be adding deionized water until you bring that bottom of the meniscus so it rests on the line in your volumetric flask. You'll want to invert it and mix your solution. And once you have solution 3 at the correct volume, you're going to transfer it into a labeled beaker and save it for later in the experiment. The last solution that you're going to be making, solution number 4, is a very dilute copper sulfate solution. The calculation that you're doing in this case is you're going to calculate what is the concentration of solution number 4. To make solution number 4, you need to measure out 4 milliliters of your stock solution, which is solution number 1 again. You want to get a small graduated cylinder to measure out 4 milliliters of solution number 1, and then you want to transfer it into your volumetric flask again and add water to dilute it up to the line. At that point in time, you'll have 100 milliliters of your very dilute copper sulfate solution. You want to transfer that into a labeled beaker, just like you did for solutions 1 through 3. At this point in time, you're going to have 4 different solutions in your labeled beakers, so it'll look something like this. The test that you want to do for your solutions in this experiment is we want to test their conductivity. And to test the conductivity, we're going to be using a ceramic spot plate. You want to get disposable plastic pipettes and fill 4 separate wells on your spot plate, like you can see in the picture here. To test the conductivity, we're going to be using these conductivity testers. And there's a few things that I want to point out here. The first thing that you have to notice is the on-off switch at the top of the conductivity tester. First, you want to turn it on. The next thing you want to notice are the electrodes at the bottom of the conductivity tester. You're going to dip those electrodes in each solution that you want to test. If the solution conducts electricity, it'll complete the circuit, and what you'll be observing are these red and green lights at the top of the conductivity tester. The reason why there's 2 lights on the conductivity tester is that it's semi-quantitative. Based on the intensity of the red and the green lights, you can determine the relative conductivity of the solution, and to do that, you need to use this laminated sheet that you'll obtain along with the tester. What you can notice on this sheet here is that there's a numeric scale. For each solution that you test, you'll want to assign a number from 0 to 4 to describe its relative conductivity, and you'll do this based on the intensity of the red and the green lights. You can then translate those numbers into terms like low, medium, high, or very high, and you can use those terms to describe the relative conductivity of your solution. To test the solutions, you'll want to dip the electrodes into each solution. It's really important that you remember to rinse off the electrodes between each test. You don't want to contaminate the wells on your spot plate, so remember to rinse off the electrodes of the conductivity tester with deionized water between each test. This is the data table that you'll be using to record your data. The first row, where it asks for the color intensity of the solution, that's just a qualitative observation. You're going to describe the color of solutions 1, 3, and 4, and you can use terms like dark blue, light blue, or very light blue. The next row, where it says conductivity tester response, what I suggest you record there is the scale, or that number that you assigned each solution when you did your conductivity tests. So what I would record there is a number from 0 to 4 to show the relative conductivity of your solution. In the last row of your table where it says interpretation of conductivity tests, here I would record that description of the conductivity. So here I would record the term low, medium, high, or very high to describe the relative conductivity of the solutions that you test. Once you've recorded all of your data and you've finished your conductivity tests, at this point in time you can pour all of the solutions down the drain and wash the glassware in the sink. This is the end of your procedure, and I hope this video helps you prepare for lab.